Hello everyone, my name is Mohammad Mehdi Reza and I am the member of group number 6. The topic of our presentation is Optimize Attentive Masking in BERT for Semantic Textual Similarity. I'm gonna introduce you with the background of our research. Actually, the topic is closely related with the applications of natural language processing, NLP, machine learning, and deep learning techniques. NLP, as you may know, that NLP is one of the most hottest research topics of 21st century, and there are numerous researches which are being conducted and going on in several domains of NLP and machine learning. Maybe NLP or natural language processing is kind of a new term for some of our audience, so I'll just give you an idea about it. Natural language processing is a new technology which helps computer understand the human language which we use in our daily life. For example, you can see Google text-to-speech or speech-to-text conversion. How do Google convert your speech into text or written text into speech? There are NLP algorithms running behind the scenes. So, there are various other applications of NLP like machine translation, sentiment analysis, semantic similarity, and a lot more. Our area of research is based on one NLP application, which is textual semantic similarity. I'll take an example to make you understand textual semantic similarity. If we search for a word or a phrase on Google or any other search engine, we get several documents and a huge number of links related to that particular word. That is basically the semantic similarity algorithms which are running behind in the background of all search engines. There are a lot of other applications of semantic similarity, including recommendation systems, search engine optimizations, and a very lively example is hashtagging on Instagram and Twitter search. For instance, if we search a word on a particular trend on Twitter or Instagram with hashtag, we get a number of links and a number of different posts related to that particular trend or related to that particular word being searched. Semantic similarity is also text embedding in which words have similar meaning. Words which have similar meaning have a similar representation. Semantic similarity is one of the major research topics nowadays globally in the field of natural language processing. And our research is also basically on an algorithm which is based on NLP techniques and more specifically text semantic similarity. And now Ali will explain our aim of research.
Our research is related to algorithm which is based on NLP technique. NLP demand the data in the form of words. Dealing with text data is problematic since our computers, scripts, and machine learning models cannot read and understand text in any human sense. NLP has the technique to convert the word data in vector form. Machine learning algorithm do not accept the actual words as their input. We have to give them the numeric data for training purposes of prediction and classification. NLP convert the word in vector forms. Our main aim is to enhance the performance of the existing state of the art algorithm, uh, which is BERT algorithm. We will modify the characteristics of current algorithm and will examine the accuracy of vector encoding. Vector encoding is one of the most important factor uh, in NLP technique because the algorithm only understands the rather than word representation, and the vector encoding has a direct impact on the accuracy of the model. We can see a number of vector encoders in the picture, and there are different vector encoders like transformer, elmo, universal sentence encoder, and BERT. There's been a lot of work going on Some of the research questions are whether the word will be more accurately semantic similar or not. Semantic similar words are those which are similar in nature and they have uh, very less distance between their vectors. And another question is, will the obtained vectors be more accurately encoded than the state of the art algorithm? After modifying the current algorithm, will predict whether the vectors are more accurately encoded than the state of the art algorithm. Another question that arises is, what would be the accuracy of the proposed algorithm? We will we will compare the accuracy of the modified algorithm with the state of the art algorithm, and we'll see what is the impact of modification on the accuracy of the algorithm.
Research pipeline. The diagram that you see in front of you is the research pipeline that is followed in most of the machine learning algorithms. As you can see, there are numerous phases in the research pipeline, namely the data extraction, data preprocessing, sampling, the word-to-vec representation, the ML algorithm phase, the performance evaluation phase, and the similarity visualizations phase. Starting from the data extraction phase, in this phase, we are going to extract large chunks of data from the Wikipedia, or it can be data from other corpus, or the data from the frequently changing websites. As this is a large chunk of data, it is then going to be passed to the data preprocessing phase. So the data preprocessing phase is responsible to transform this raw data into some efficient and useful format. As this is a large chunk of data, it is then going to be divided into three different data sets, namely the validation data set, the training data set, the test data set. This segregation of the data will be obtained with the help of the sampling technique. The validation data set is responsible for checking the validity and the accuracy of the training data set. The training data set is the main focus here, as this data set is the one which is going to train our word-to-vec representation model. The word-to-vec representation model is nothing but our enhanced BERT algorithm. The output from this enhanced BERT algorithm will be the encoded word vectors, which are going to be the input for the ML algorithm. The ML algorithms which are used here are the ANNOY and the FAST, and these algorithms are responsible to find the semantic similarity between the words. According to the ML algorithm ANNOY and FAST, the words are semantic similar if the distance between the two word vectors is less. Now the next step is the performance evaluation. The performance evaluation of the entire pipeline can be done with the help of the test data. And this test data will also help us to find out how words are semantic similar. The next is the research methodology. There are two research methodologies which we are going to use in our research pipeline, namely the simulations and the sampling. The research pipeline itself is a combination of small pipelines which can be easily achieved with the help of simulations. Moreover, simulation is a flexible methodology and we can achieve a high level of completeness with the help of simulation. The simulation techniques or the different simulation machines which we are going to use here are the GPU, which is a graphical processing unit, or the TPU, which is a tensor processing unit. The next research methodology is sampling. So as we have a large chunk of data, applying sampling is a very nice approach here, as to draw conclusions from a large data set is very difficult. So we will take out some data samples from the large data set and draw conclusions with the help of these small data samples. So now the next slide will be explained by my friend Osama.
This is Osama, and thank you, Sadesh, for explaining the research pipeline and methodology with great significance. And from now on, we are going to look at the technical aspects of our research project, which is the word-to-vector representation phase. And for that thing, we are going to refer the BERT algorithm, which has been developed and represented by the Google, and it has significantly outperformed number of state-of-the-art NLP techniques for several machine learning tasks. So BERT is the bidirectional encoder representations from transformers, which is basically used for pre-training a large amount of unlabeled textual data to learn the language representations for several machine learning and deep learning tasks. So in simple words, we can say that the preprocessed words are transferred or are passed to the input layer of the BERT architecture. That we can see in the diagram, in the depicted diagram, that the words are passing to the input layer of the BERT architecture, and they are converted into the tokens at the embedding layer. And after the embedding layer, the tokens are being passed to the transformer encoder, and then they are passed to the layer of neural networks. And then at the output layer, we will get the encoded vectors, which will going to be the input for our next phase, that is the machine learning algorithm stage. So talking about the BERT, we have major components in BERT that are associated with the performance and accuracy or the predictive analytics metrics in the BERT architecture. So the first one is bidirectional encoder, and the second one is the MLM, which is the mask language modeling, and the third one is NSP, which is the next sentence prediction. All right, so the BERT has used previously proposed major two concepts in machine learning, which are the attention mechanism and transformers. So, for example, if we can see the first picture where it's an illustrated sentence that is, she is eating a green apple. So there is a high attention over the three words, which is on eating, green, and an apple. So the attention thing is related to the concept, the basic concept that, for example, in a sentence, we can have two types of attention, the low attention words and the high attention words. So the high attention words are the words which can give us the nature or the basic semantics of that particular sentence. So the BERT has focused over the high attentive words. The second thing, the transformer. The transformer is basically a stack of the encoders. For example, if I am going to give an input, a word input to a transformer, so the words will going to be entered as input to the first layer of the encoder. All right, and the output of the first layer of encoder is going to be the input for the second layer of encoder, and this process will go on according to the architecture of the transformer, that how many encoders will going to be in that particular one transformer or with a layer of transform. So these two concepts are used by the BERT, and these two concepts are being built in the architecture of overall BERT algorithm. So our prime focus, our research focus is to change the masking, the attention mechanism. The attention mechanism in our proposed algorithm is to change the mask language modeling from 15% to 25%. That means we are going to increase the attention in our overall algorithm. For example, if we are going to increase the attention thing in our overall 100% words corpus, so that means we are going to give more attention into the algorithm, into the word to vector representation phase. So this is our proposed mechanism of the BERT algorithm, and this is the characteristic that we are going to modify in the BERT algorithm. And from now on, Navdeep will gonna continue. Thank you.
Thank you so much, Osama. My name is Navdeep Kaur and I am here to present the result derived from traditional BERT algorithm in comparison to our modified algorithm. So talking about the implementation, after the implementation of the modified algorithm, the predictive accuracy will be enhanced because we have increased the MLM from 15% to 25%. And for that, we are going to use machine learning evaluative measures like accuracy, recall, and F1 score to evaluate the performance of our trained models. Secondly, there will be a probabilistic score between the words, which will be evaluate the semantic nature between the words, and the word vectors which will be derived, they will be more accurate, but yes, the time required will be increased. We are going to use visualization technique to show up the semantic similar words using the principal component analysis, which is PCA. So therefore the semantic textual similarity between dynamic words would be more absolute from the modified algorithm. However, every coin has its own two sides. Every project has ethics and constraints associated with it. Talking about the ethics, the data which we are going to use will be legal. Legal in the sense we are going to fetch data from Wikipedias, web pages, etc. And every individual whosoever associated with this project will be honest toward their work and will never be deceptive. However, we have read number of articles on this project, or you can say on the BERT algorithm. So therefore, we have come to a conclusion that the models trained during this period require 4 to 5 days, and there is also a requirement of TPUs and GPUs as well. So it can be said that for the BERT algorithm, it is a long process which needs exceedingly long time, and this remains in the case study of constraints. So these were the ethics and constraints which were in relation to our modified version. Thank you so much. This was our project. Any questions, please?